Okay, we're going to pause on the math stuff for a moment with the solutions, and let's talk about some factors that affect how what the molarity would be of a specific solution. So let's first talk about some terms, and I think you've heard of most of these terms before, so they should hopefully will be a review. So when we talk about saturation, when we talk about solution, first of all, we're going to talk about unsaturated solution. Unsaturated means more solute can be dissolved. Okay, very simple. So whatever it happens to be, you can still dump in more. Okay, it's sort of like your hot tea, where you put in 1 spoonful of sugar and you stir it up and it all disappears, and you put a second spoonful of sugar and you stir it up and it all disappears. That means you've still got an unsaturated solution. You can still put more sugar into that hot tea. A saturated solution would be when the maximum amount of solute has been dissolved. Now, this is kind of hard to see sometimes. So think again let's think of iced tea instead of the hot tea example. So you dump in your sugar, you dump in a couple of spoonfuls of sugar, and you stir and you stir and you stir and you stir, and no matter how much you stir, there's always that little bit of sugar that's left over on the bottom. That's a saturated solution at that point, because that sugar that's on the bottom cannot dissolve in the iced tea anymore. So it just sits there on the bottom doing nothing to the actual solution. So there's the maximum amount of sugar molecules dissolved in this iced tea at that particular moment. And then the last one is a supersaturated solution. A supersaturated solution occurs when more than the maximum amount of solute has been dissolved. Notice this statement here. Okay? The only way to create a supersaturated solution is to saturate it. It's like saturate your solution, raise the temperature, saturate it at the higher temperature, and then cool the solution back down nice and slowly. The best example of something like this is rock candy. To make rock candy, what they do is they boil water and they dump in the maximum amount of sugar that can dissolve at the boiling point. Then they cool the water back down, and as they cool it back down, the sugar crystals actually, the stuff that was dissolved now crystallizes out of solution and forms that weird crystal-y type structure along the stick. If they didn't put the stick in the solution, it would cool back down and be a saturated solution of sugar water. It would never crystallize on its own until something was put in there to actually cause the crystallization to occur. Speaking of causing the crystallization to occur, let's look at a great example of a supersaturated solution. I apologize. Let me start that again. Okay, so this is a supersaturated solution of sodium acetate. So what they've done is they've taken water, they've boiled the water, they've dissolved a certain amount of sodium acetate in the boiling water, and then they've cooled the solution back down. Notice it looks like water. Okay, there's nothing special about it. So they're going to drop a single crystal of sodium acetate into the solution and watch what happens. Notice the crystallization occurring. Okay? All of this stuff that's saturated inside the solution wanted to come out and form crystals. But the problem was it had nothing to cling to until that one single crystal dropped in. And once that one single crystal dropped in, it started forming from that point on. And it solidified all the way through. And that's a supersaturated solution of sodium acetate. Now sometimes you can do fun stuff with sodium acetate too. For example, fun with sodium acetate. Don't worry about the narration. I'm a better narrator. Okay, so they created that supersaturated solution. Now watch what happens when it hits the dish down here. They've put a single crystal on there. And when they pour the saturated solution onto there, it begins to crystallize immediately and form a solid. And you can see it's perfectly clear here and white here. And it forms this little solid mound as it goes. And that's fun with sodium acetate. Okay, so now let's talk about the other situations in which you can change the solution. First of all, solute-solvent interactions. The problem with chemicals are they have different levels of intermolecular forces. Some substances, no matter what you do, can't dissolve in others. Read this as oil and water. Oil and water don't mix. Why don't they mix? Because they have wrong intermolecular forces. Okay? So why does oil and water why don't oil and water dissolve in each other? The key phrase here is like dissolves like. Okay? What does this mean? This means nonpolar substances dissolve nonpolar substances, and polar substances dissolve polar substances. So remember we talked about intermolecular forces. The intermolecular forces must be the same or similar in order for it to dissolve. This is where the term solubility comes in. You know, you may have heard the phrase like, oh, that's not oil is not soluble in water. Well, why is oil not soluble in water? Because the intermolecular forces are not the same. Oil has dispersion forces, water has hydrogen bonding. They're not the same. Oil can't dissolve. Salt is ionic. Salt is extremely polar. Polar substances dissolve in polar substances. So salt loves to dissolve in water. Lots of ionic compounds are like that. Potassium nitrate, lead nitrate, etc. Anionic compounds are going to dissolve in water. So because water is always polar. Something you also might hear sometimes is water is what's called the universal solvent. Okay, because something like 75% of our world is polar, and because it's so much of it is polar, water is able to dissolve everything. This condition here, this solute-solvent interactions, is the reason why dirt and grease don't wash off your hands and clothes that easy, because water can't dissolve them. They're nonpolar substances. However, detergents can. Detergents are extremely, extremely, extremely long chains of nonpolar compounds linked together, and on the very, 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 very end is a polar piece. So imagine a huge chain of molecules, boom, 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 and at the very, 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 very tip is polar. So all of this here is nonpolar, and this very, very tip is polar. Why? Because this very, very tip can bond to the water molecules and go woo down the drain as you wash your clothes, and it grabs all that dirt and grease and grime all along the way. Okay? So that's the beauty of solvent-solute interactions. Other things that you can do to affect concentration: pressure. Okay? Pressure only affects gases. Why? Well, there's no pressure in a solid or a liquid. Now, if you increase the pressure, you can increase how much solute can dissolve. For example, soda. Soda is a great example of changing conditions to affect how much can dissolve. Carbon dioxide does not like to dissolve in water, but if you pressurize it, it will, because you force the molecules to bump into the liquid. Think about soda. The first time you open the cap, you hear that sound. That's the pressure being released, and as soon as you release that pressure, bubbles come rushing to the surface. There were no bubbles there before you open the lid, but now there are bubbles after you open the lid. And that's because the pressure is released and the carbon dioxide no longer can be dissolved. The last one is temperature, and we know temperature. Temperature we see all the time. If you increase the temperature, you increase how much solid or liquid can dissolve. If you decrease the temperature, you increase how much gas can dissolve. So in this one, again, coming back to my soda example, warm soda goes flat faster than cold soda. Why? Gas molecules like to move around. If they gain energy, they can't stay dissolved in a liquid any longer. Okay, so when they get warm, like in warm soda, they come rushing out of the solution very, very quickly. If it's cold, soda will stay bubblier longer. For the first one, think hot tea versus cold tea. You can dissolve a lot more sugar in hot tea than you can in cold tea. Okay, so if you increase the temperature, increasing how much solid and liquid can dissolve. This very much has to do with the collisions of the molecules in the solution. Then they're hot, they move around more, they can bump into the solids and liquids more, therefore they can dissolve them more. But gas is about energy. And the more energy it has, the less likely it is to be dissolved. And those are factors affecting concentration.